Hi, I'm Harsh Sikpal, Senior Software Engineer at Keysight Technologies, and this is a quick introduction to ASTRA-sim Service. Me and my team at Keysight, in collaboration with Georgia Tech, have developed, ASTRA-sim Service. And the idea is that we wanted to simplify configuring and running ASTRA-sim simulations. This is a link to our repo. It's on GitHub under ASTRA-sim.org, and the repo name is ASTRA-sim Service. And as you can see, we have a README which talks about the development environment and the deploying methodologies. So since this is a quick introduction, I'll show you how to clone and build the repository and what is the dev container setting for this. So let me quickly clone this. So I already have a folder in my desktop called GitHub, and I'll just do a git clone and I'll paste the link. Give me 1 second. Sorry. So now, since ASTRA-sim service has been cloned, I'll just open this using Visual Studio Code. And as you can see in the README itself, we have stated that we use dev containers to, have the perfect environment to develop and run ASTRA-sim simulations. The base image is Ubuntu 22.04, and I have already, launched my VS Code in that particular folder. So as you can see, we get a notification about opening the same in a dev container. And on clicking this, it's going to launch that particular dev environment. It will load all the dependencies, which is required by ASTRA-sim service as well as ASTRA-sim. And you can see in the logs. Yeah. So this is up. Now, a quick walkthrough on the, you know, on the repository structure. So before I move to the repository structure, the main commands to, build everything is to just do a make install prerequisites, and we do a make build all. So these commands are going to, install all the dependencies like Chakra, Infragraph from Keysight. And it's also going to build this service. It's also going to run some test cases, in the service code. So as this is going on, I'll quickly go through the repository structure. And as you can see, we have a few folders over here, and the main folders are the models, service, and client scripts. The models hold, the schemas, which are written in OpenAPI art format. And if you go back to the browser, the repository, you can just see a link over here, which gives you the whole schema. This is again written in OpenAPI art style, and you can see all the APIs that are present, as well as the schemas that are used by those APIs. So, like for instance, this is a set config API, which uses a schema, which takes the infragraph as well as the AstraSim configurations into account. So please feel free to check this link, and it will give you a good insight on how the service is implementing these APIs with certain schemas that the client also uses to send to AstraSim uh, service. Now, since the models is about schema definition and how it generates an SDK using OpenAPI, we have the service folder which implements the AstraSim service. It's a gRPC service, and it uses the existing or the generated SDK from the schema that we have defined, and it has a server. So we have written a server on top of it that takes all the configurations, and it also implements those APIs and runs Astra-Sim simulations. Now, one thing to add here is that when you do a make build all, it's also going to clone Astra-Sim from GitHub, and it's going to build that because the service is going to, uh, run or trigger Astra-Sim simulation. So to run ASTRA-sim, we definitely have to clone and build it, and make build all does the job. So moving on to the third aspect of our repository, the third directory is the client scripts. And this holds the notebooks, which contain sections, relevant sections to run ASTRA-sim simulation. So as this is being built, I'll quickly go through one of the notebook, let's say an NS3 sample dot Python notebook. So the idea is that we want the notebook to connect to the ASTRA-sim service, which you can see here. Before that, we import certain helper functions and libraries that are required. And using the SDK that is generated by the models, and we have powered, AstraSim client, the client scripts. We have written a wrapper that does the job. So it implements the SDK that is generated by models. And using that, we are able to, generate workload. We are also able to configure the system configurations, all the other existing configurations which AstraSim uses, as well as the network backend. So, over here you can see like how NS3, we are able to configure the NS3 config file as well as the topology, as you can see here. The notebook, once we are done with configuration, we call a function which is called run simulations, and that's going to run the uh, NS3 backend simulation because we are passing NS3 as the backend name. And once this is done, we download the configurations, as a step. So this is an optional step which you can do because if you want to get all the files from the server, this is something that you would be interested in. And then we can, read the output files and print them. So almost all the notebooks follow the exact same procedure, importing necessary libraries, connecting to the ASTRA-sim service, configuration of ASTRA-sim specific configs using the Fluent API and the SDK, and calling the run simulations API, and then the download configurations. So let's wait for this to be over, and then I'll just run this notebook quickly. As you can see, we had 34 test cases and all of them had passed. And this signifies the end of the build process. So this has run some test cases on the scripts, client scripts. The service, it has built the service, built ASTRA-sim as well, and then ran the test cases. Now, we'll be running the service and we will be running a client notebook as well. So to run the service, there are mainly two options. I'll be showing you how to run it in a standalone manner. So you can just do cd service and Astra server, and you can just do Python. And if you do an ls, you will just see it has a main.py. So to run the service, you can just easily do Python 3 main.py. And this launches the gRPC service, and it checks for all the backends if they are present or not. And it also, showcases the IP address and the port where the service is running. Now, as I had explained in previously, that we had certain steps on running the notebook. The first one is importing the necessary modules. So in this example, I'll be using the same notebook, which is ns3 sample.py, and we'll be running the same, blocks. So over here, I'm importing the necessary utility scripts as well as helper code to help me run the simulation. Now, I'll be connecting the ASTRA-sim client notebook to the server. So as you can see, I have mentioned the server endpoint as the same as whatever the service has emitted. This ASTRA-sim call is nothing but a wrapper call which takes help of the SDK and minimizes API calls to the ASTRA-sim service. Over here, we are going to generate the workload execution traces. So again, the utility, the ASTRA-sim has its own function that allows you to generate the collective. So you need to pass the collective type, the size of the data size, and then the NPU range. And on running, it's going to generate, the workloads in a specific folder. So you can see that, it has generated the workloads in trial and ST trial configurations workload. So if you look at transcripts, we have the trial folder, we have the NST trial, and then we have the configuration, and you can see that the workloads are generated here. So the idea is that, the tag that you put here in the Astra service, ASTRA-sim call, a folder is created with the tag name, and, it creates like a unique identity for each run that you're trying to do. Now, we'll be configuring the system configuration, like, we are setting the endpoint delay as 10, the local memory bandwidth as 1600. And on running it, you can see that I'm printing the whole system config as it is, whatever I have configured. Then we configure the remote memory, and then we move to the network backend. So we are running on MS3 backend. And over here, we are, giving the trace IDs for every rank that we have assigned. The logical dimension is set to 8, and we are setting the payload size as 8192. Then we'll be setting the network topology. So this is, direct configuration to the NS3 topology that is present as a part of the network NS3 network backend. And we are adding all the connections. We are giving this number of switches as 1, total links as 8. And the next thing is we are configuring the CMD parameters, like the COM scale, injection scale, and so on. Then we have a generic call, a wrapped call, which is called run simulation. So this is going to run the ASTRA-sim simulation using NS3 backend. We pass the backend as a parameter to the function. And once the simulation is successful, it is going to send back the results file back to us. So as you can see, I clicked on it and it's running the NS3 simulations. And it also tries to fetch the generated results file from the ASTRA-sim service or the Astra server. And you can see over here in the NS trial folder, let me do a quick refresh. And you can see that the output folder contains all the results file that are generated by the simulation run. Moving on, we can also download all the zip files as all the config files as zip. These are the files which are generated, using the set config API call. This is something that you may choose to use if you want to see or if you want to retrieve the config files from the server. Now, the last step is, we'll be reading these output files and generating some kind of tables. So on clicking on it, you can see that we are reading the fct.csv, which is this file, and we are displaying that in a tabular format. And we also do some level of processing, like we generate the flow stats, and you can see that we get some more detailed results. So this is all about the ASTRA-sim service. We have a bunch of sample notebooks for every backend, as well as we have a few notebooks where we have integrated Keysight infra graph. So please feel free to use them and let us know how it works right. Thank you.